Strict environmental mandates are rapidly targeting styrene emissions across the composites industry. Formulators are being forced to reduce styrene levels, and the immediate physical result is often a thick, highly viscous resin that refuses to flow. This baseline chart illustrates the crisis on the manufacturing floor. Historically, standard resins provided a wide, forgiving green processing window. Under the new low-styrene mandates, that operational safety net is shrinking down into a highly restrictive red margin of error.
OnlyTRAININGS. Learn what works in the industry.
Erasing styrene volume on a spreadsheet is a simple calculation. Executing that same reduction on the factory floor without destroying your production process is entirely different. A specific misconception drives these production failures. Manufacturers often treat styrene as a simple, cheap solvent, used purely to thin out the bulk mix. Operating under that assumption pushes formulators into a corner. They find themselves forced to choose between passing regulatory compliance testing and maintaining the mechanical integrity of their final parts. To understand why formulations break down, we have to look at what styrene actually does. Mechanically, it dictates the baseline viscosity of the entire liquid system. That controlled low viscosity is the engine that drives reinforcement fiber wet out during complex composite layups. Mechanically, styrene is critical. This network diagram shows small reactive styrene molecules acting as rapid bridges between larger polymer chains, defining gel time. As crosslinks form, the network manages peak exotherm, evenly distributing heat release across these structural bridges. Aggressively pulling styrene out of a working formulation removes the viscosity control, the curing bridges, and the thermal management systems simultaneously. Therefore, hitting an emissions target by reducing volume is a math exercise. Replacing every physical and chemical function that styrene performs is the actual formulation problem. Let's look at the first common formulation trade-off: cutting styrene content purely to satisfy immediate emissions targets without adjusting the rest of the chemistry. This cause and effect formulation matrix maps out the consequences. Aggressive styrene reduction results in an exponential, uncontrollable spike in base resin viscosity. Applied to dry reinforcement fibers, the manufacturing trade-off is a complete breakdown in wet-out. The viscous resin fails to penetrate the fiber bundles. This leaves localized dry spots and generates microscopic voids trapped deep within the composite structure. Under physical load, these internal voids act as extreme stress concentrators. A microscopic gap becomes the exact point where the structural part cracks and fails. This specific wet-out failure cascades across production methods. It ruins sheet molding compounds, bulk molding compounds, standard resin transfer molding, and large-scale infusion processes. Passing an environmental emissions audit holds zero value if the final composite part shatters in the field due to a compromised internal matrix. To solve the viscosity problem, formulators often attempt a second fix, swapping the missing styrene completely evenly with an alternative reactive diluent or monomer. Returning to our matrix, we see why this fails. A one-to-one monomer swap leads directly to altered network formation, rewriting how the polymer bridges form. Without the original styrene architecture, the new reactive monomer generates highly unpredictable peak exotherms compared to the historical baseline of the resin. This thermal volatility causes gel times to drift wildly from batch to batch. The secondary consequence is severe, drastically altered shrinkage behavior as the part cures. This erratic shrinkage pulls on the internal fibers. It physically warps the final part, damages expensive precision molds, and completely deteriorates surface cure in delicate gel coats. Introducing a new reactive monomer requires a customized, highly calibrated cure strategy. The concept of a true drop-in replacement is a myth. This leads to a third incredibly costly trap: optimizing a styrene-free formulation solely as an unreinforced neat system in a laboratory setting. On the lab bench, a formulator can easily dial in the perfect glass transition temperature and excellent toughness metrics inside a test tube. But success in a controlled beaker rarely survives the complex mechanical friction, pressure, and thermal demands of real-world composite manufacturing. Looking at the final row of our matrix, optimizing solely for neat resin properties directly causes composite underperformance. Flow, rheology, and complex fiber interactions dictate commercial success, not baseline lab metrics. Relying on unguided trial and error to reverse engineer viscosity, cure, and shrinkage on the factory floor creates a massive financial drain on operations. Companies waste months of lab time, accept excessive material scrap rates, miss critical go-to-market windows, guessing the exact chemical balance. Relying on a cycle of failure and slight adjustments drains your R&D budget while offering zero guarantee of a scalable, viable commercial product. Overcoming the low-styrene paradox requires abandoning the concept of simple monomer replacement entirely. A successful low-styrene or styrene-free system demands a ground-up redesign of the resin architecture, strict cure control, and precise rheology management. This scorecard outlines the barrier. If you are fighting highly viscous resins, batch-to-batch cure drift, and failed fiber wet-out, you need a new operational blueprint. OnlyTRAININGS provides exactly that. The Low-Styrene and Styrene-Free UPR and Vinyl Ester Resins course is designed to bypass the trial and error loop entirely and deliver working formulation strategies. This expert-led training is the most cost-effective path to recovering mechanical performance and securing your processing window before emissions targets tighten further. This training is engineered specifically for active unsaturated polyester resin formulators, vinyl ester developers, and composite manufacturing engineers. It is highly technical and built strictly for industry professionals actively working on the floor, not for academics looking for theoretical textbook chemistry. You will gain advanced, actionable insights on reactive diluent selection, managing shrinkage and exotherm, recovering fiber wet-out, and troubleshooting low-styrene failures during scale-up. Registration grants you 6 full months of access to the complete training ecosystem, allowing you to review the materials as your projects evolve. Most importantly, you gain 24/7 direct access to active industry professionals via the Expert Connect discussion forum, allowing you to ask highly specific technical questions and troubleshoot your exact formulation failures. If your manufacturing window is shrinking and emissions mandates are threatening your production capability, regain control of your formulation. Click the link in the description to register for the training today.